convention.
He's a geneticist.
Yes, yeah.
Prediction.
So, prediction. Which one feels colder?
Computer feels colder,
Computer feels
but
colder.
it's gonna melt the ice cube faster than the table.
So, well, we'll see what happens. We'll see what happens. So, basically, yeah, you touch both objects, and obviously the computer feels a little cold. So, if we look at it from the perspective of our hands, we touch it and we say, oh, this one feels cold. So, automatically we're thinking this must be colder. But let's see from the perspective of the ice, which one feels colder. Because the ice is not as warm as our hands. So, what happens, I place a piece of ice on both pieces of equipment.
This guy.
That's great. Yeah, just put it
Oh, yeah, there it is.
There we go. Go. So observations, what do you see?
Sounds quicker on the computer.
So based on what you can see, from the ice perspective, which object is colder? What do you say, Ted?
So it's got those.
If it was really hot, it quickly melt. So this goes into the definition of temperature. What do we mean by temperature? Because actually, starting off, both objects would have been the same temperature. Because the room and everything inside the room, both of the table and the computer have been sitting in the room the entire time. And eventually all things go to thermal equilibrium, which means they all come to the same temperature. So this means that means really what we feel is a bad measurement of temperature. Another simple demonstration that you could show this is you take one hand and dip it in a bucket of hot water, another hand dip it in a bucket of cold water, wait for a minute, and then put them both in a bucket of lukewarm water, room temperature water, and you'll feel that one feels colder, one feels hot, even though it's the exact same temperature. Because what we feel is not a sensation of temperature. What we feel is a sensation of heat either leaving our hand or coming into our hand. And all of that comes down to what he said, thermal conduction. So metal is very quick at transferring heat. It's quick at transferring heat to the ice, and it's quick at taking the energy out of our hands when we touch it. So if we wait for this piece of ice to completely melt, we'll pretty much give up all that heat, and then you'll feel the top of this computer get pretty cold. And the effects are really obvious if you have like a cooking pan. That pan gets really cold after it melts a piece of ice. So where does this apply? Think about going into a car, for example, during the summertime. What always burns you when you get into a hot car?
The seat.
The steering wheel. Or if you have leather seats, it's much worse than getting in those nice little velvety seats. Or that buckle always gets you. Common misconception is that buckle must be at a higher temperature. In reality, everything in a car is the same temperature. So, it's just
I think of like metal slides during the hot summertime.
Yeah.
You know, if little kids go in shorts, because you're talking about little kids, which would be hotter going down a metal slide or a plastic slide. Or, you know, since I'm older, going to football games, on cold football games, and putting your butt on the bleachers.
Yeah.
What happens to your butt? It gets cold.
yeah, absolutely. And if you're going to sit on metal bleachers, now that you know this, what could you do to eliminate that effect?
The blanket. That too.
Put some thermal insulating.
Literally a bun warmer.
Bun warmer. Exactly right. Exactly right. So this just a simple demonstration.